All right, so this whole chapter is about modeling relationships between variables with straight lines. And sometimes that relationship is given by data. We've collected data and it looks like it's pretty linear, and we'd like to be able to write a line, or write an equation for a line that best fits that data. And so that's what we're going to talk about today. We're going to talk about the method of least squares. Sometimes it's called linear regression. Um, where we've got a bunch of data and we want to find the best fit line. We want to find the line that best fits that data. Now we could just take a couple of points, and then we could say, well, it looks like maybe if I just connect up these 2 points, P1 and P5, right? Yeah, that looks like it's, kind of fits the data. But we don't know if it's, and given those 2 points, we could write an equation for a line with those 2 points, but we don't know if it's the best fit. And so that's the idea behind this principle of least squares. We want to look at look at the distances between those points and the line and minimize those distances. And we're actually going to minimize the squares of the distances, because sometimes the distance is negative and sometimes it's positive, and so we're going to square it so that we get positives, and we want the sum of those squares of those distances to be as small as possible. All right, now the process of figuring out how that all works is kind of beyond the scope of this class. So a miracle occurs, and all of a sudden we have these lovely equations. All right, so let's talk about how these equations work. So if we're given n data points, so let me kind of highlight what's the key things here. We're given n data points, all right? And we want to find the slope and the y-intercept. We want to find the slope and the y-intercept for the line that best fits that data. And so that's what this is. The slope, here, maybe I should make this, so here's the slope right here. This is the slope. And the y-intercept, maybe make that a different color here. Let me make that pink. So here's the y-intercept, right? The y-intercept and the y-intercept, okay? And these values here, so here's n. N is the number of data points, right? This n is the number of data points. This is the sum of all of the x values, okay? Sum of all the x values for the points that we collected. This sigma of y is the sum of all the y values. We also need to sum up all the squares of the x values and the sum of all the products of x and y. Okay. Now this looks really messy, but let's see how this works in an example. Okay, so let's take a look at example 1. We're given some points, right? These are the x and y coordinates for these points. We have 5 different points, and we want to find a line that best fits those points. All right, so let's just list out the information we have. So the first point is 1, 1. So its x value is 1 and the y value is 1. Point 2 is 2, 3. So the x value is 2 and the y value is 3. Okay. Point 3 is 3, 4. So 3, 4, x and y. 4, 3 is the next one. So x and y, those are the x and y values. And then we have 5, 6. Okay, we have these 5 points. All right, so what we're going to do is we're going to sum up all the x values. 1 plus 2 plus 3 plus 4 plus 5. We get 15. All right. Sum up all the y values. 1 plus 3 plus 4 plus 3 plus 6. I get 17. Okay. So this is what they were calling the sum of xi. Okay. This 15 is the sum of xi, and this is the sum of all the y values. So in our formula, it looks like sigma xi. All right. It looks ugly, but it's not that bad. It's just a number. It's just a number. All right, now we're going to take the squares of all the x values. All right, so we're going to square 1 and we get 1, square 2, you get 4, 9, 16, 25. And then we're going to add those all up. Okay, so what I got was 55. Okay, so this is the thing in our equation that says the sum of xi squared. All All right, that's what this is right here. And then we're going to take x times y. All right, so 1 times 1 is 1, 2 times 3 is 6, 3 times 4 is 12. Here we have 3 times 4, or 4 times 3, which is again 12, and then 5 times 6, which is 30. And then we're going to add those all up. I get 61. All right, so this is the sum of x, I, y, I. Okay, that's in our equation. So we found all of these quantities. We found the sum of all the x values, the sum of all the y values, sum of all the x squareds, and the sum of all the xy values. Okay, and then we're just going to use these quantities in the last row here to set up the equations. All right, we're gonna use these formulas up here and just substitute in for those sums, and also the n. So n is a number of data points, right? So in this case, n is equal to 5. Okay, so we need n. All right, so I can't really have both of these things on at the same time. So why don't I will just write down, I'll write down the formulas again. So down here, so it's n times b. All right, we're going to solve for b. So maybe I'm going to make that red, okay? Because that's something we're going to solve for. That's a variable. And these things in green that I'm going to write in green are just constants that we've already figured out. All right, and then we want plus the sum of the x values times m, and that's something that we're going to solve for, right? That's our slope that we're going to solve for. And that's equal to the sum of all the y's. Okay, so that's just going to be a linear equation that we're going to solve. Okay, and then, okay, all I'm doing is copying the formula down again so you can see it, since I can't have both of them on the same screen. So the second equation is the sum of all the x values times b. Okay, I should probably put parentheses around these. And then we have the sum of all the x squared values, xi squared times m. Oops. And then that's equal to the sum of xi, yi. Okay, so now we can substitute the values that we got here. So n is equal to 5. So I'll just write it over here. So we have 5b, I'll write it in red, 5b plus the sum of xi we found was 15. So 15, I should probably just make that plus. 15 m is equal to the sum of the y values, that's 17. Okay, and then this one, sum of all the y values is 15. Sorry, the sum of all the x values is 15 times b plus sum of x squared is 55 m. Let me make that a red so you can. Okay, and then that's equal to 61, the sum of all the xy values. Okay, so you can see we just have a system of linear equations. Okay, we have a system of linear equations, and then we have to figure out how to solve that. So there's any number of ways we could solve that. Now I am seeing that if I just multiply this first equation by 3, or maybe even -3, then I can eliminate a variable. So what I'm going to do, I was just going to multiply this equation by -3, just because I want to eliminate a variable. Okay, so all I'm doing is trying to solve these two linear equations for m and b, and then I'll have the slope and y-intercept for the line that best fits this curve. All right, so what I'm going to do is if I multiply that first equation by -3, I get -15b plus, or no, minus, because I'm multiplying by -3, minus 45m equals -3 times 17 gives me a negative 51. Okay, and then I'm just going to copy the second equation as is. 61. All right, and then you can see I can just add those two equations, and that eliminates the b variable, right? Because minus 15b plus 15b is 0. Okay, so I think I copied that wrong, didn't I? This should be 55. 55. Okay. So now, if I add those up, I get 10m is equal to 10, which tells me that m is equal to 1. So that's my slope. All right. I'm just trying to find the slope and the y-intercept for a line, the m and the b value. So once I have the slope, then I can just put it back into one of the equations, the original equations, right? So if m is equal to 1, I'm just going to take that first equation, 5b plus 15m, but m is 1, is equal to 17. And then I'm just going to solve for b. So I'm going to subtract 15 from both sides. I get 5b is equal to 2. So b is equal to 2/5, or I could write it as 0.4. Right? So now I have m and I have b. Now I'm going to write the equation for the line. All right? Y equals mx plus b. Y equals m, which is 1, right? So 1x. I don't really have to write the 1 though, since it's, anything times 1 is itself, so I don't really need that. So it just becomes x plus b plus 0.4. Okay? So that is my best fit line by the method of least squares. All right? It takes some practice. It's really just a matter of filling out the table, finding those constants, the n, the sum of all the x's, the sum of all the x squareds, the sum of all the xy values, putting them in the equation and solving that system of linear equations. All right, so I'll meet you in the next video for the next example.